Hi, and welcome back to another little physics video. We're looking at forces again, and we saw in the last one about Newton's first law, and we thought that the force changes the way the body moves, or anything moves. Alright, so let's look at what he said again. But this is a different law. Right. Mr. Newton said there was a big relationship between force and mass. Right? We saw before that we need a big force to move a big mass. But if we've got a force and we've got a little mass, it's going to cause it to move a lot differently. As we can see by this TV detective kicking down a fence, he has a much bigger mass than the fence and kicks at it and causes it to spring open. Right, so let's look at these basic things. Bigger things will need a bigger force to make them move. That's because they have a bigger mass. So we're saying that the size of the force we need to move something will depend upon the mass, or how many particles it will be. In real terms, this is about kilograms and grams of something. So if it's bigger, we have trouble moving it because the mass is bigger and we have problems that way. Right. He also said that there's a relationship between force and acceleration. So if I've got an object and I want it to move faster or accelerate, change its speed and make it go faster, then I have to provide a bigger force. How fast I want it to go means how big a force I need to apply. So on our picture here, we've got the Star Trek, and we've got it moving at warp speed, which is supposed to be really fast. So that means the amount of force it's pushing must be really big. All right? Now, if we look at these things, they tell us together. So now we're at a stage, we've got force is linked to mass, and force is linked to change in speed or acceleration. So Mr. Newton decided he would make this into a formula. And here F for force equals the mass times the acceleration. Now this means if I've got a constant or the same size force, if the mass is big, the A has to be small because they are multiplying together to make this the same number. Right, if the mass is small, the A will be bigger for the same reasons. So we can see that if we can know any one of these three, we can talk about what the other thing is going to be. For example, if we know how big something is and how fast we want it to go, then we can work out how much force we've got to use. So this is a really handy sort of a formula for us to use. Now, we probably won't use it too much in this year, but down the track, you will probably use it a lot more. All right, maybe we might get to the third law for Mr. Newton in the next